This podcast is brought to you by LMU Munich.
Our next talk here is by Justyna Janczyszyn, and it's about infrastructure as code. Please.
Okay, so hi everybody. I'm very happy to be here with you today. So I've already been introduced, so I'm a software engineer at 10Clouds, which is a Polish software house. We have offices in Warsaw, Poznań, and Wrocław. So because we're a software house, we have many small to medium projects, which is kind of why the topic that I'm going to be talking about today is especially important for us. Okay, so with infrastructure, there always seem to be some problems, like logging to servers, changing stuff, because you weren't sure, do we have the right packages? Maybe not, did I manage to do everything that I was supposed to do? So I log into different servers, and then we get this configuration drift. And so in one server we have one version of the package, then in another we have another version, and basically it's a big, big mess. And then people get angry and it's messy. The other thing is that with infrastructure and provisioning, if we don't do it automatically, there are a lot of tasks that are very repetitive and very, very boring. So imagine that maybe at the beginning you have only one server, maybe two, but then, for example, your project grows and you have 10 servers, 20 servers, and more. So at that point, it's basically impossible for you to manage the infrastructure manually. So basically you need automation, otherwise it's just going to be a waste of your time. So yeah, basically we don't want to be logging into our servers and changing stuff there. It's not very good. I'm going to say why. Because there's going to be a big, big mess. And what it causes also is a phenomenon called Snowflake Servers, which basically means that suddenly we end up with servers to which nobody has any idea what's going on there. How do I make a server like this again? Because, for example, my system is running on it. And what if the server dies and then suddenly I have to rebuild it? How do I do that? I don't know, because I didn't have an automated process. So there is something called the fear spiral, which basically, if you are not using an automation tool, or you are kind of using it, but only sometimes, then if you make these changes, for example, outside of this automation tool, your servers are very likely to become inconsistent. And then once that happens, you're becoming more and more afraid of changing stuff because, oh no, what if the server breaks? What if my application doesn't run anymore? So we don't want to be afraid. We want to be confident when we deploy new changes. And we want to make sure that at any time we are able to rebuild our server from scratch. Also, another thing is that you usually have a lot of people on your team, on different teams. So there's something called the bus factor. So it's not only about, somebody may die. They might, but, So it may be also that, for example, they change jobs and they are not there anymore. So if they, for example, provisioned your server and set up everything, and maybe they didn't document it very well, or maybe they did, but, later they did not update it. So you don't really know where you are. So this is also something that we want to avoid. So we've got a lot of problems. What do we do about them? Well, infrastructure as code principles and practices are coming to the rescue. Okay, so let me first talk about a couple of principles. Oh, and the part right now is actually based on the book called Infrastructure as Code by Keith Morris, which I recommend to everybody if you're interested in this topic. So, the first thing is, any element of the infrastructure should be easily reproducible. So, in this time and age, with the cloud servers, it's very easy for us to spin up new servers, new infrastructure. And so having that ease, it's very important to be able to manage it in an automated way. So like at any time, we should be able to spin up new servers without having to think about it too much, like how big should the server be, like what about the security groups and stuff. Like this should be already ready for you, defined somewhere, and you should be able to just run the command and it should stand up and make your system work again. So this also is very important for fault tolerancy, especially if we have like big systems with a lot of servers. There's always something bound to go wrong. Like we cannot predict it often, we cannot help it, so we have to be able to react very quickly and make sure that even with the failures, we are able to ship new servers as soon as that's needed. Okay, so basically everything that's about provisioning and spinning up new servers should be automated, and there should be tooling to enable us to provision it. The other thing is that systems should be consistent. So let's say we have a couple of servers. We want them to be provisioned the same way. We want them to have like the same packages installed. And then, for example, okay, we can say that one of the servers needs like a bigger capacity because it's storing more files. Great, perfect. Then what should we do? We should probably create like a new definition file where we would say that this is a different class of server, and because the needs are different, here it's like a new type, but it still should be, we still should be able to spin it automatically. So basically, we need to be able to trust our automation tools, and that once we have taken some decisions, we can redo them quickly. Yeah, so another one, like the process should be repeatable. So any task you carry on your infrastructure, we should be able to repeat. So if it can be scripted, it should. So for example, you may say that, I don't know, resizing your disk is a one-off task because like you need it now, but then like for a very long time you may not need it. But like probably it will happen in the future, and probably it will happen on the other servers. So why not have a script for it? Why not automate it? Also, like different people can do it. So what if one programmer does it this way, then the other that way, and then we get still these inconsistent servers, and we don't like that. Okay, so the last one is that design is always changing. Basically, we have to make sure that we can deliver and deploy changes quickly and reliably, because this lets us perform small changes, deploy them as soon as they're ready, and then like we have with continuous integration and continuous deployment, we are able to deploy new functionalities fast, and we are also confident in our automation tools because we are using them all the time, and we don't get afraid that, oh no, I have not used it in such a long time, and what's going to happen, I'm not sure. Like, we should be always sure what's going to happen. Okay, so let's go to best practices. Basically practices of infrastructure as code. So, as I already might have said, like, we use definition files. What does it mean? Like, so there are very many options out there right now. Today I'll be speaking about CloudFormation, but like probably you are maybe familiar with Ansible or Puppet or Chef or Terraform. There are a lot of options. Just choose whatever works best for you. So also, thanks to using definition files, we get self-documented systems and processes. So we don't need to create external documentation, because basically these things, especially if they are declarative, like for example CloudFormation is, so basically there we already specify how our infrastructure is going to look like. So basically, okay, you could create documentation from it. Also, you could create it automatically if you need some other format, but basically everything's there. So, which leads us also to versioning all the things. So we have user definition files, which also are our documentation, and then if we put it to a version control system, like we get very clear compliance and audit. We can go back in time to see how our infrastructure looked like a couple months ago, I don't know, maybe years, days. Yeah, so at any time we know what was going on and what changed, so we are not worried about this bus factor anymore so much because this information does not disappear. Also, what's great about this is that you can actually do like code reviews on your infrastructure files, and this is also great. Okay, so the next point would be to continuously test the system and processes. So just like you do with your code, you would have like probably some continuous integration running your basic tests to make sure that any changes made don't break the system. Then you probably would have some pipeline with continuous delivery, where you would have like some more complicated tests. You could spin up like environments for your quality assurance and stuff like that. So basically, you can apply the same principles to infrastructure. So basically, for example, you could have a Jenkins server which would have like as one of the automation build steps would build the system, for example. Also, because you have all your infrastructure defined, it's very easy to spin up and then delete when you don't need it anymore. So you can do this as quickly, as often as you need. And well, then you are kind of sure and confident that if anything were to go wrong, you can rebuild your infrastructure quite quickly. And that also that it works. Okay, so another thing is to have small changes rather than big batches. So basically, it's just like with code. If you have like a lot of commits that you suddenly push to, I don't know, the master, and you test it and you want to deploy it, like there's gonna be errors probably, and it's gonna be a lot harder to find them. So the same goes for infrastructure. If you make small changes and you continue to kind of improve your system over time, that's going to be great, because like small change, you can identify the problem very quickly, you can fix it, and well, you don't stop the process, you don't create like traffic jams, let's say. And okay, so here also what's very important with these changes and stuff is testing, automated testing for infrastructure, so which was actually in continuous testing, and the other thing is monitoring of your infrastructure. This is very, very important. There are many different services you can use for monitoring your infrastructure. You could have some in-house services. We sometimes, for example, use Datadog, which seems quite good. Also, if you're using CloudFormation, you can set up CloudWatch alarms, which can also be set up by CloudFormation. So basically, you get everything together. So, like, even if the test pass, if you have monitoring, you can see that, for example, the load is not that big, but the requests are too slow or something like. You can identify a lot of issues, and you always want to be able to do that. And so with infrastructure as code, if you can implement it together with like definition files, that's even better, because like then you have a ready infrastructure plus monitoring, for example. And the last point would be that we want our services to be available continuously. So it's not like it's like 2016, right? So we don't really want to have extensive like maintenance windows. I know, because my clients get annoyed when we ask for that, so that's bad. We don't want that. And also, like, if the service goes down, that's really, really bad, and it should not happen, especially if you have tools like this at your disposal. So an example of what we could do to make our services available continuously is, for example, a practice called blue-green deployment, where we have our infrastructure and our system working, and then we deploy or provision another stack of our infrastructure just next to it. There we deploy our system, we run our tests to make sure that it's working correctly, and then like once we're confident that we have the entire system, like the replica of the system but with the updates, working and running, we can simply switch the traffic to this new system. And the old one, it depends. Like we could simply delete it, dispose of it, because then we can recreate it anytime we want. But okay, so no, actually don't delete it. Maybe wait a little while, and then if you find out that your new system with the updates after all has something wrong with it, then you can do a really quick rollback. So yeah, sorry, don't delete it. Not so soon. Okay, so at least wait, I don't know, maybe a day. Yeah, okay. So let's go to CloudFormation now. Oh, did I say about all the benefits? Okay, so obviously CloudFormation, obviously infrastructure as code is very, very important if we go into scaling or microservices, because there you have like a lot of systems that have to run independently, and also like you have a lot of pieces that are kind of the same for the system, like, I don't know, for example, VPCs, virtual private clouds, or yeah, basically many, many things. So if you don't automate stuff there at scale, you're gonna die. Okay, so CloudFormation. CloudFormation is a service by Amazon Web Services, and basically it lets you in an easy and manageable way create AWS infrastructure, manage it, delete it, update it, and it keeps everything ordered and predictable. Basically, what it does is you create some template files where you describe your infrastructure that you need. Okay. From that, so this described resources plus their dependencies, and this together is called a stack. Stacks are a unit, so when you create a stack, either all the stack is created or none of it. So for example, if something goes wrong, there's an automatic rollback, so you're not afraid that, oh no, I have all the services and the others I do not have, and then what am I gonna do? No, it's gonna automatically delete itself. And also, for example, you spin up new stack and you don't need it anymore, it's very easy for you to delete it and not to have to pay for it anymore. So what I like about CloudFormation, this is simply just an example of services that are spin up by CloudFormation stack. The thing is that there are many, many various complex scenarios, and for a lot of them, there are already available templates that you can find online, for example, offered by AWS team or some other developers that probably that are going to cover some of your use cases. So you don't have to come up with these templates by yourself, but you can use something that has already been defined, also by probably people that probably know a little bit more than you about security and the resources. And another thing that is important for us, for example, is that we're a software house. So we have a lot of small projects and a lot of different teams. So when we create a template for a sample project, for example, using Django and using RDS, and the common stuff stays there. You basically can reuse the same template. So you don't have to spend time on implementing it once more. You don't have to spend time clicking and manually provisioning the infrastructure. So it's very handy, very useful. Okay. So for example, this is how it would work. Green-blue deployment would work with AWS CloudFormation. You would spin up the other application stack with the servers, and you could dispose later the old one, and then obviously you would probably keep databases and stuff because they keep your data and are not updated as often. Okay, so we don't have too much time, so I'm just going to show you quickly. Unfortunately, I don't have internet connection here, so I'm just going to show you screenshots from the demo. So this is how you would create a stack. So there on top you have the repo with my code. And so this is how you create a stack. Templates, maybe. Okay, I'm just going to go through slides, and then in the end, I'm going to show you code. Okay, so with CloudFormation, you get both the console, so you get user interface, it's quite nice, but you can also do everything from command line, which I personally like. Because then, for example, you can add it to Jenkins server and have it provision everything for you. You don't have to click anywhere, but still you can check out stuff here. So here you get like, there I have a couple of stacks. There's an overview. Here, for example, I see all the events that are happening. Here I see all the resources that have been created. So I have it all in one place. So it's very convenient. And here I have the outputs from the stack. So for example, these are the things that I would probably put in my Django settings for my application. So you can also describe stacks, and you would get something like this. So this is from the console, from the terminal, for example, right? So no GUI, you can do everything on command line. You can also delete the stack. Oh, which is great, you can create change sets. So once you create a stack and you want to update it, you can do kind of a dry run, which is going to tell you that, for example, it's going to add this and these resources, it's going to delete this resource, and then like you can see, oh, is that what I wanted? And you can say, okay, let's go for it, or no, that's not what I wanted, let's stop. Oh, another thing, you can do cost estimation. For example, for your, you have a client, they want a project, and you say, okay, we're going to need such and such servers, and then you can prepare an estimation for them. This is just an example. So here you have like outputted everything, all your services, the costs, and it's all calculated together. Okay, thank you.
Justyna, thank you very much for your talk. We do have time for a few questions.
Okay.
I have a question about non-disposable resources. I mean, sometimes you need to upgrade the database, and it may not fit as well in this, in the way that you still need to like create a copy of the database.
Okay. Let me.
Before you answer, please repeat the question so
Yeah,
it's on.
okay. So if we have a database, what do we do if you want to update it? We don't want to dispose simply of the database, right? Okay, so CloudFormation actually has something called policies, where you can specify that with database, whenever you want to change this resource or you want to delete it, first, let's do a snapshot of the database. Also, you can connect it together with creating a new database using the snapshot. So there are ways to manage it.
So you mentioned that you need to test your continuous integration and continuous deployment of configuration files. In your opinion, what is the best approach to do that?
Okay, so the way I would do it is, okay, so yeah.
Question, please.
Okay, how to do continuous integration with how to test infrastructure, right? Okay, so probably the way I would go about it is I would have like a Jenkins server, I would have two different repos, one for the infrastructure stuff, the other for the code stuff. And then like one of the steps of the build would be probably to spin up the infrastructure and to make sure that once I deploy the application to the infrastructure, that the system is working together, basically.
The AWS policies for creating, removing stacks or whatever parts, they are, from what I've seen so far, fairly extensive. How do you make sure that whatever continuous integration servers you use, you're not giving too much permissions to then shut down everything?
Sure. So, okay. So with continuous integration and deleting infrastructure from Jenkins, for example, about policies, if they are not too extensive, how to make sure that doesn't happen. So first thing is that you can have policies saying that you cannot destroy these resources. Another thing is that with CloudFormation, you can actually create these policies as well. So basically, there are a lot of different policies for stuff like that also. And also, you should probably create like dedicated roles for your Jenkins server to make sure what it can actually touch.
So, thank you very much.